Hello friends, in this video we are going to see about types of inhibition. The first inhibition is competitive inhibition. Competitive inhibitors are substrate analogues, the compounds which resemble the substrate and they compete with substrate for the active site of the enzyme. Enzyme plus substrate gives enzyme substrate and then it gives enzyme plus product. So the rate of forward reaction is K1 for the ES is the intermediate complex, ES complex. So enzyme substrate complex. So rate of the forward reaction for the first step is K1 and rate of the reverse reaction is K minus 1, and the inhibitor competes with the substrate for the active site of the enzyme, but to bind with the active site of the enzyme. So after E plus I gives Ki and the reverse reaction is K minus I, so EI. So this is the way in which the competitive inhibition takes place, and this equation we will take it as A. So assuming rapid equilibrium, there are two types of equilibrium: rapid equilibrium and quasi steady state equilibrium. Here we are assuming rapid equilibrium. In rapid equilibrium, the forward reaction rate under is equal to the reverse reaction rate. So K1 into ES equal to K minus 1 into ES. So K minus 1 by K1 equal to E into S by ES. So here we write this K minus 1 by K1 as Km dash. So here the M Km dash or Km prime, so equal to ES, E into S by ES. So this prime denotes that it is a rapid equilibrium. So V is equal to K2 into ES. So rate of equation for this is the rate of equation for V is the rate of the equation, and this is for getting the converted to products. So this equation we will name it as 3, and overall we have that concentration of enzyme, initial enzyme concentration is equal to concentration of enzyme plus concentration of enzyme into enzyme substrate plus concentration of enzyme inhibitor. So this is the overall in a way in which the enzyme concentration gets distributed. So in equation 3 we substitute V is equal to K2 into E, we substitute 2, second equation is Km dash E into S by ES. So we substitute that and we arrive at the value E into S by Km dash is equal to V by K2. So in fourth equation is this equation, we substitute 2, the same way we substitute, and then we get the, after substituting we get the values like this. So finally this way we get in this equation after substituting the values, and we will try to get in this format like 1 plus I by Ki into E plus V by K2. So this K2 into E naught is nothing but V max. So maximum velocity of the maximum velocity or the maximum rate of the equation. So we take the LCM for, in order to get the K2 to the other side, we take the LCM. So K2 into E plus into 1 plus I by Ki plus V the whole by K2. So K2 into E naught, K2 we take to the other side. So or we can say that we will multiply this K2, we will multiply both sides by K2 by V. So if we multiply by K2 by V, so E naught into K2 by V is equal to E into 1 plus I by Ki into K2 by V plus 1. So we get V max by V equal to K2 E into by V into 1 plus I by Ki plus 1. So K2, therefore since K2 ES is equal to Km dash V, implies K2E is equal to Km dash by V. So V max, we after substituting and cancelling out the terms, we get the value like V max by V is equal to Km dash into 1 plus I by Ki plus S. So now here there is values 1 is there. We have this S substrate value. So substrate we take it to the numerator here, and the whole divided by S. That value has got cut down here. So that whole divided by S value is still here. So next if we go, this value Km dash into 1 plus I by Ki, we take it as Km dash app, and V max by V we take it as the V max by V will become Km dash by app by S plus S. So we will say like V max into V by Km dash app plus S is equal to V. This is the equation for competitive inhibition. So where V max is equal to K2 into E naught and Km dash app is equal to Km dash into 1 plus I by Ki. So here the Km dash value alone has got affected. In competitive inhibition, Km dash app value alone has got affected. In non-competitive inhibition, non-competitive inhibitors are not substrate analogs. Inhibitors bind on sites other than active site and they reduce the enzyme offering to the substrate. So E plus here in this case non-competitive inhibition, they bind here with enzyme as well as to enzyme substrate complex. So this enzyme after binding to enzyme EI complex also becomes ESI. So Km dash, this is Km dash here. So finally we substitute, similarly we write down this equations and then we substitute the values. We get we write down this equation E naught is equal to E plus ES plus EI plus ESI. So we substitute the values from there. All the similarly we take this rapid equilibrium, and rapid equilibrium we write down the values here. These values are like competitive inhibition, here the rapid equilibrium values, and then we substitute those values and then we arrive at similar way. We arrive at 1 plus I by Ki into E plus V by K2, that is equal to E naught. So we get V into 1 plus K2 by K2E by V into 1 plus I by Ki equal to V max. Therefore V is equal to V max by 1 plus Km dash by S into 1 plus I by Ki. So this is the equation for non-competitive inhibition. So here Km dash is there as such, and here and this value we will see like we will again substitute like Km dash app, we can substitute and then we can get the value. And a non-competitive inhibition, third one. So here E plus S gives ES, and here the inhibition doesn't bind to enzyme, it binds to the enzyme substrate. So here we get the values. Similar way we do the calculation here. Therefore we get E plus ES plus ESI, and then we do the multiplication, we substitute the values, and finally we get the value. This big value we get V is equal to V max into S by Km dash plus S into 1 plus I by Ki. So V is equal to V max S divided by 1 plus I by Ki divided by Km dash by 1 plus I by Ki plus S. So by writing this Km dash value, Km dash becomes Km dash app and V max becomes V max app. So finally if you see mixed inhibition is similar to non-competitive inhibition. The equation, this is here the equation is written, and in this mixed inhibition the alpha is in most cases we like for simplification we take it like in non-competitive inhibition we take as alpha is equal to alpha dash. As per Leninger's book, they have mentioned like alpha is equal to alpha dash is rarely encountered, and where alpha is equal to 1 plus I by Ki. So Ki dash is equal to Es into I by ESI. So we write down these equations, and then the final value we get similar to non-competitive inhibition. This is the value V equal to V max S by alpha Km plus alpha dash into S. So alpha dash is equal to 1 plus I by Ki dash and Ki dash is equal to Es into I by ESI. So alpha is equal to 1 plus I, that has been told before. So substrate inhibition finally. So high substrate concentrations may cause inhibition in some enzymatic reactions known as substrate inhibition. E plus S is equal to Km dash ES, the whole gives E plus enzyme plus product K2. So ES plus substrate, high substrate. So in the enzyme substrate complex another substrate binds causing ES2. So this rate of the reaction is taken as KSI. So KSI rate of reaction is like a rate of assuming rapid equilibrium. ES2 into KSI is equal to S into ES. Km dash is equal to S into E by ES. And Km dash is equal to K minus 1 by K1. And similarly KSI is equal to K, we will take the value as KS by K minus S. So K minus S by KS. So KSI, that is KSI. So we write down these values, and Km dash is equal to S into E by substrate into enzyme by ES. So where Km dash is equal to K minus 1 by K1. So V is equal to this things like from first competitive inhibition it comes. So here we write down again rate of our product formation. V is equal to K2 into ES. V is equal to K2 into E into S divided by Km dash. So we write down this whole enzyme concentration reaction. E naught equal to E plus ES plus ES2. So E naught is equal to E plus ES E into S by Km dash plus S into ES by KSI. And finally we write down the values, and here E plus E into 1 plus S by Km dash plus S into ES by KSI. So S into ES by ES we write down as E into S by Km dash. So E into 1 plus S by Km dash plus S into E into S by Km dash into KSI. So E we take down commonly out. So then we see that 1 plus S by Km dash plus S square by Km dash into KSI. So next we take down the like LCM of this Km dash along, we to multiply throughout by Km dash. So Km dash into E naught equal to E into Km dash plus S square by KSI. This is equation 1. So we know V is equal to rate of product formation is equal to K2 into ES. So that is equal to K2 into S into E by Km dash. So K minus 1 into ES equal to K1 into E into S. So Km dash is equal to K minus 1 by K1. Sorry, that is equal to E into S by ES. So is equal to E into S by V by K2. V by K2, that is, so because V is equal to K2 into ES. So substituting Km dash from A, this equation we take it as A in 1. We cancel out the common terms, and then we arrive at the value K2 into E naught equal to V max, implies V max into K2 into E naught equal to V max. Therefore, which implies V max into S by V into equal to Km dash by Km dash plus S square by KSI. So this is the final equation. That's it. Thank you. There are various types of inhibition graphs corresponding to the types of inhibition. So all these types of graphs which are shown on screen are double reciprocal plots. So double reciprocal plots, we plot 1 by substrate concentration versus 1 by rate of the equation. So if you see for competitive inhibition, when the inhibition is greater than 0, when there is no inhibition, I is equal to 0. So when I is greater than 0, this value is getting in y-intercept, the x-intercept, the value is minus 1 by km app is there in the x plot, and this minus 1 by km is in the negative side. So this means, so as we can see, minus 1 by km app is greater than minus 1 by km as per the graph. So when there is competitive inhibition, so when this is the case, that means since negative value is greater than the negative value, that means the positive value 1 by km is greater than 1 by km map. So 1 by km is greater than 1 by km map, because for example minus 1 by 2 is minus 1 by 3 is greater than minus 1 by 2 means, that means 1 by 2 is less than 1 by 3. Positive 1 by 2 is less than positive 1 by 3. So that is what is represented here. So which means when we take again the reciprocal, then again km will be less than km up. That is 1 by 2 will be greater than 1 by 3, but 2 will be less than 3. That's what is represented here. And in uncompetitive inhibition, the I is greater than 0, I equal to 0, those two are like parallel lines. And if you see for non-competitive inhibition, so just notice competitive inhibition means binding to active site, and uncompetitive means binding to enzyme substrate complex, and non-competitive means other than the active site. So I is greater than 0 in all the cases. The y-intercept value, if we see for uncompetitive, it is 1 by Vm app, and for here when I is equal to 0, 1 by Vm, 1 by velocity maximum is less than 1 by velocity Vm app, that is the new value 1 by Vm app after inhibition. So that means that Vm 1 by Vm is less than 1 by Vm app, means Vm is greater than Vm app. So similarly 1 by Km is less than -1 by Km app, means the same logic comes here as like, and then we conclude that Km dash, so here everywhere there should be like a Km dash, because we have assumed a rapid equilibrium. So -1 by Km dash, so Km dash app is greater than Km dash, so Vm greater than Vm app. And then for non-competitive, so in this way the inhibition takes place. So as per text, reduction in both Km dash and Vm values, and new Vmax is less than Vm. So new Vmax value is less than Vm. That's what the conclusion is. So here for this one, first one, competitive inhibition, Km dash app is greater than Km dash. So that means reduced reaction rate. So reduced reaction rate, Km dash app is greater than Km dash, means Michaelis-Menten constant, new Michaelis-Menten constant after inhibition is greater than Km dash, means old Michaelis-Menten constant, means that means reduced reaction rate. And then for non-competitive inhibition, similarly if you see here the plot is converging, both the I greater than 0 and I equal to 0, they both are converging in -1 by Km, and like here 1 by Vm app, and here 1 by Vm. When I is equal to 0, the 1 by Vm is less than 1 by Vm app. So reduction in Vmax value, that's what the non-competitive inhibition does. And substrate inhibition, 1 by Vm is here, -1 by Km is there in the x-intercept. So Km dash by S is very less than 1. That means that is drastically less than 1. They are the substrate concentration is very high. At a high substrate concentration, inhibition is caused. So these are the inhibition graphs for the types of inhibition we saw. And for mixed inhibition, if we see, it is similar to non-competitive inhibition mostly. And there are some small details which might be missing. Kindly please excuse. This is as per the text which I have seen. So, and there might be more details if we refer to more experienced lectures or experienced notes or book. Thank you.